Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 14C of rectilinear figures. Also, to opt for my online lectures and online test series, email me. Check the description for more information. In the exercise, we are going to solve a few sums. Now mark the following sums as IMP: 7th sum, 9th sum, and the 19th sum. Now before we start with the first sum, remember after the exercise is over, you need to solve all the solved examples as well. And here we also have some extra questions proving sums, proving from question 1 to 11. So make sure you prove these as well on top of the exercise and the solved examples. Here the given is not given, so you'll have to draw the diagrams, write the given to prove it entirely. Each sum is of one whole full-scape sheet, so there are very huge sums, so make sure you do all of this. No, I'm kidding, you don't have to do this, just do the exercise and solved examples. Now question 1, as you read it, always try to draw the diagram on your own so that you understand where you are wrong while drawing it. Now here ABCD is a parallelogram. F and E are midpoints, and we have to prove that AEFD is also a parallelogram. Now remember, whenever we have to prove a quadrilateral as a parallelogram, we just have to prove a pair of opposite sides equal as well as parallel. So if I can prove that AE is equal to DF and AE is parallel to DF, then it's proved that AEFD is a parallelogram. Automatically then AD and EF will also be equal and parallel. So we know that in ABCD parallelogram, AB is equal to DC, opposite sides of parallelogram. So half of AB will be equal to half of DC. That means AE is equal to DF because F and E are the respective midpoints. So I have now proved AE is equal to DF, and of course they are parallel because they are already opposite sides of this parallelogram, hence proved that AEFD is a parallelogram. Here's the solution. Now this is question 3, and this is what we have to prove in question 3. There are 3 parts to it. So in the diagram, ABCD is a parallelogram. E and F are points of trisection, that is AE is equal to EF is equal to FC. First we have to prove that DE is parallel to FB, and we also have to prove them equal. So I'm going to prove the Roman number 2 first. I'm going to take triangles DAE and triangle CBF, and I will prove them congruent. Let's see how. So we've got side equal to side, opposite sides of the parallelogram. Then I've got this angle equal to this angle. It's forming a Z, as you can see. So these are alternate angles, and DA parallel to CB. Always mention the parallel sides, the parallel lines also. So I need one more thing for congruency. Well, it's given that AE is equal to FC. So which test is this? SAS test of congruency. So this means that DE is congruent to FB by CPCT. So that's Roman number 2. Now let's go for Roman number 1. We have to prove DE parallel to FB. Now how do we prove two lines parallel? There are some tests, if you remember. We have the corresponding angles test, the alternate angles test, and the co-interior angles test. So here, first of all, this angle is equal to this angle by CPCT. That means this angle, which is a linear pair of this, will be equal to this angle, which is a linear pair of this. If this is x, this is 180 minus x. Similarly, if this is x, this is 180 minus x. So these two angles are equal. And if you notice, even this is forming a z. So if these alternate angles are equal, hence it is proved that this is definitely parallel to this. So that's how we prove Roman number 1 as well. By the way, even these x and x angles are alternate angles. They are called exterior alternate angles, which is not very commonly used. Hence, I've proved the interior alternate angles equal first, and then it became parallel. Now, Roman number 3 is prove DEBF as a parallelogram. Well, that's pretty simple because we have already proved that DE is equal to FB, and now we have proved DE parallel to FB. So that means it's a parallelogram. In fact, in the exam, I will ask only Roman number 3, not Roman number 1 and 2, but you will still have to solve the entire sum. So it'll be interesting to know whether it strikes you how to go about solving the sum. Oops, why did I say it right now? Now look at the solution. Even here, make sure you write each and every step which I mention with all the reasons and in the logical order in which it is mentioned. That's the only way you can score full in geometry. Now, this is the fifth sum. What's given is that ABCD is a parallelogram and AE and BE are the respective angle bisectors, and we have to prove that AB is twice of BC. So first of all, we know that this angle is equal to this angle, let's say x and x, but this angle is equal to this angle, alternate angles, because DE is parallel to AB. This means that angle DAE is equal to angle DEA. That means DAE is an isosceles triangle. That means this side is equal to this side. Similarly, I can prove that this side is equal to this side. Now, imagine DE is, let's say, A and EC is B. So this becomes B and this becomes A. Now DC is equal to AB, opposite sides of parallelogram. So how much is AB now? It's A plus B. So AB is equal to AD plus BC, because even this is A plus B. So AB is equal to AD plus BC. But isn't AD and BC equal? Aren't they equal? Because they are opposite sides of a parallelogram. So I can say now that AB is equal to AD plus AD, or I can say AB is equal to twice of AD. Anyway, I'm not going to use A and B in the sum. We are going to use proper names of angles and sides. So whenever you solve this, after each step, keep looking at the diagram to understand what's happening. Now the seventh sum is IMP. Prove that the bisectors of interior angles of a parallelogram form a rectangle. Here the given is not given, so You'll have to write the given. Did you get the diagram right on your own? ABCD is a parallelogram, and AP, DP, CR and BR are the angle bisectors. They are all intersecting at these points. Prove that PQRS is a rectangle. Not only is it a parallelogram, but it's a rectangle. That means we have to prove each angle to be 90 degrees. If I can prove at least 3 angles to be 90 degrees, then the sum is over. Then it is proved that it is a rectangle. So first of all, we know that opposite angles are equal. That is, angle A entirely is equal to angle C. Let's assume they are equal to 2A each, and these two angles are 2B and 2B. And since these are angle bisectors, so I can say this is A, and I can say this is B, angles. Now I know that this entire angle plus this entire angle is equal to 180 degrees because they're actually co-interior angles between these two parallel lines. Or I can just say adjacent angles of a parallelogram are supplementary. That means 2A plus 2B is 180. That means A plus B is 90. So that is the first step to get A plus B equal to 90. Now, in triangle APD, if I use angle sum property, then that means angle P plus A plus B is totally 180. But out of that, A plus B is 90. That means P is also 90. That means vertically opposite, even this is 90. So since just like this is 90 by vertically opposite angle, similarly I can prove that this is 90 and vertically opposite this is also 90. But here I need not show all the steps. I will just write similarly. So now I've got two angles 90. That's not enough. I need one more angle is 90 degrees. So now let's talk about triangle DSC. Again, in triangle DSC, this is B and this is A, and B plus A plus this angle will be totally 180 degrees. Angle sum property. Out of that, A plus B is already 90. So how much will this be? 90. So hence it is a rectangle. So this is the solution. Don't forget to write given and to prove. These are the steps, further steps, and don't forget this final statement here, otherwise you lose half mark. Now the ninth sum, again, even that is an IMP sum. In fact, it's similar to the fifth sum, quite the reverse of the fifth sum. So in this sum, again, ABCD is a parallelogram, and here AP is an angle bisector, but we have to prove that BP is also the angle bisector. And in this sum, it is already given that AB is twice of AD. So we'll start with these angles. Let this be an X and this is also X, although I have not used X in the sum, but you may use it if you want to. Also, this angle will be equal to this angle. Alternate angles test. It's forming a Z. That means now these two angles are equal. So this is an isosceles triangle. So this side is equal to this side. Isosceles triangle property. Now we know that AB is twice of AD. That means if AD was, let's say, A, then AB would be twice of A, as per the question given. But AD is equal to DP, so DP is also, let's say, A. Now DA is equal to CB. That means CB is also A. Now AB is equal to DC, opposite sides of a parallelogram, just like these are also opposite sides. That means DC is entirely 2A, just like this was 2A. But if DC is 2A and out of that DP is A, how much is PC? That's right, PC is also A. That means P is the midpoint of DC. Interesting. So that's how we have proved it. But what I actually wanted to prove is that now PC is equal to CB. So first I proved DA equal to DP, then indirectly I have now proved PC equal to CB. Keep looking at the letters. Now that means this is an isosceles triangle, so this angle is equal to this angle, isosceles angle, triangle property. But this angle is equal to this angle in interior angles because this is parallel to this. That means this angle is now equal to this angle, which proves that BP is the angle bisector. So that's your Roman number 1. But I have to prove this angle to be 90 degrees now, Roman number 2. Well, let's assume this has x and x and this has y and y. Although actually in the sum I have used a and b here, but the logic is same. Now we know that this entire angle plus this entire angle is 180 degrees because they are adjacent angles in a parallelogram. That means 2x plus 2y is 180. That means x plus y is 90. Now in triangle PAB, let's use angle sum property. So angle P plus x plus y is totally 180, but x plus y we proved as 90. So how much is left? 90 degrees. Here's the solution. Further, and final steps. Now the 12th sum. Try to draw the diagram on your own. Let's see if you can get it. This was the diagram. Of course all sides are equal, but also DQ and AP are equal and they're intersecting at O. Now don't assume that P and Q are midpoints. Never assume anything in a question. Read the question very carefully. Now in this sum, I have to prove first of all that AP is equal to DQ. I guess that will be by CP/CT. So I need two triangles. Which two triangles should I take? Guess. Guessed? Well, did you guess these two triangles? DAQ and ABP? Because here DQ is given equal as AP in the question. DA is equal to AB, sides of a square, and 90-90. So that's which test? No, that's not an AS test, it's RHS test. So by CP/CT, I can say that this angle is equal to, let's say, this angle. Let's call that A and A by CP/CT, of course. And this angle is B is equal to this angle. So let me call it B. Now if I draw this in the main diagram, actually now I have labeled this as A and this as B. Now in this triangle DAQ, if I use angle sum property, this is 90. So how much is A plus B? That's right, A plus B is 90. So in triangle OAQ, how much is A plus B once again? It's 90. So by angle sum property, what is left for this angle O? That's right, it's 90. So hence I have proved that angle AOQ is equal to 90 degree, which was also asked in this question. So these are the steps, and even these. Make sure you write this in the end that AP is perpendicular to DQ. Read the question, they've asked you to prove this. Don't just stop here. Just put a degree sign here. Now the 13th question. If you get the correct diagram, then the sum is very easy. First of all, they've asked us to prove that AC bisects angle BAD. Bisects means I have to prove these two angles equal, which will be by CP/CT. So which two triangles will I take? Let's take ADC and ABC. We got side, we got side, we got AC common. So by SSS test, they are congruent. That means by CP/CT, this angle equal to this angle. Hence prove that CA bisects this angle. The second part, prove that AC is a perpendicular bisector of DB. That means not only do I have to prove this angle as 90 degrees, I have to prove that O is a midpoint of DB. Not of AC, midpoint of DB. So now we'll take triangles DOA and triangle BOA. So I've got angle already proved. I've got side given. What else? Well, we've got AO equal to AO common side. So this is SAS test of congruency. That means this DO is equal to BO, and also it means that this angle is equal to this angle by CPCT. But it's a linear pair, so totally it's 180. That means 2x is 180, means x is 90. That means this is 90 degrees. Hence we have proved that CA is a perpendicular bisector of DB. These are the steps. And here. Now the 15th question. They've given a hint, join AC. You can try that method, but I have a very easy method. They have asked us to prove that APCQ is a parallelogram. Now, how do we prove anything as a parallelogram? Just prove a pair of sides equal and parallel. So, I'm going to target AP and CQ. Let's take triangle APD and triangle CQB. Let's see what do we have. Can we prove them congruent? First of all, this side is equal to this side, opposite sides of a parallelogram. What else? Well, in the question they have actually given that AP is an angle bisector and here CQ is an angle bisector. Now, the total angles A and C are equal because they are opposite angles of a parallelogram. That means their half angles will also be equal. Let me call this as A and this whole angle as A, and let me call this whole angle also as A and A, because if this angle is 2A, then this angle is also 2A, opposite angles of parallelogram. So that means angle DAP is A and angle BCQ is also A. So they are equal. So I got the second thing. Now I need one more thing. How about this? Prove this angle equal to this one by alternate angles, because this is parallel to this. So I got ASA test, ASA test. So these two triangles are not now congruent. So this means that this side is equal to this side by CPCT. Now I have to prove them parallel also. That's okay. This angle is equal to this angle by CPCT again. So this angle is now equal to this angle because this is a linear pair of this and this is a linear pair of this. So they are equal and that forms a Z. Interior angles are equal. That means AP is parallel to QC. And if the sides are equal and parallel, that means quadrilateral APCQ is a parallelogram. Next is 17 sum. Now here the given is not given. So here's the diagram. But before that, the steps of the previous sum. Here they are. Also the final steps. Now here the given information is that there is a rectangle, let's say ABCD, the diagonals meet at O. Now they are saying that the diagonals are perpendicular to each other. They intersect at right angles. Now prove that ABCD is a square. You see, in a rectangle, the diagonals can bisect each other. That means O can be the midpoint, but it is not necessary that they are perpendicular to each other. That is true only in a square or a rhombus. So that means square is a special type of a rectangle. So how do I prove this as a square? I know that the opposite sides are equal because it's a rectangle given. If only I can prove just one pair of the sides as equal, that would mean that all four sides are equal. And in a rectangle, if all four sides are equal, then that is a square. It's already 90 degrees. So how will I prove, let's say, DC equal to CB? Well, obviously that will be by CPCT. So let's prove these two triangles congruent. What do I have here? I've got 90, 90. Then I've got CO as a common side, and also DO is equal to OB. You see, diagonals of a rectangle bisect each other. That's a property of a rectangle. So which test is this? SAS and SAS test of congruency. Hence prove that DC is equal to CB, and hence it becomes a rectangle. These are the steps. The 19th sum is important. It's not a proving sum. We have to find all the values. Only one angle is given 56 degrees. EDCF is a square and DABC is a rhombus. What this means is that all these sides are equal. ED, DA, AB, BC, CF, FE, all the sides are equal to each other. Also in a square, each angle is 90 degrees, and in a rhombus, it's a parallelogram. So opposite angles will be equal, 56, 56, and these angles will also be equal. Also, in a rhombus, that's a parallelogram, the adjacent angles will be supplementary. So if this is 56, this will be 180 minus 56, and same here as well. So keeping these properties in mind, we have to find all these values. First, they've asked us to find angle DAE. DAE. So first of all, this is 90 degrees, angle of a square. And if this is 56 degrees and this is also 56 degrees, opposite angles of a rhombus, yes, you have to write all these reasons. So this is entirely 90 plus 56, 146 degrees. Now, I've already said that ED is equal to DA because both of them are equal to CD, you see, sides of a square and a rhombus. So that means EDA is actually an isosceles triangle. I can assume this angle to be x and x, and by angle sum property, x plus 146 is totally 180. So I can calculate the value of x, which will come up to be 17 degrees each. So even this is 17 and this is 17 degrees. So that's with Roman number 1. Next, Roman number 2, angle FEA. FEA, this angle, this entire angle. Well, we know that angle FED is 90 degrees because it's angle of a square. Out of that, a small angle is 17. So how much is left for FEA? Obviously, it's 90 minus 17, which will be 73 degrees. Next, Roman number 3 is angle EAC. Now, this angle, EAC. First of all, if this is 56, then the adjacent angle BAD will be entirely 180 minus 56, which is 124 degrees. 124 degrees, yeah. Now, CA is a diagonal of a rhombus. You know, diagonal of a rhombus or any parallelogram always bisects the vertex angle. Actually, that's true for only rhombus and square. The diagonals bisect vertex angles. So you can see that learning all the properties of the rectilinear figures is so important for this chapter. So if the entire angle was 124, that means angle CAD is half of 124, it's 62 degrees. Now out of 62 degrees, the small angle is 17. So what is left for this angle CAE? It's 62 minus 17, which comes up to 45 degrees. And finally, Roman number 4, find angle AEC. AEC means this small angle now. So again, angle CED is 45 degrees. You see the whole angle was 90, and again this is a diagonal of a square which again bisects the vertex angle. So angle CED is 45, and out of 45 the small angle is 17. So how much is angle CED? It's 45 minus 17, which is 28 degrees. And these are the steps. Further steps.